In this video, we will look at some examples of compound interest, and we will calculate both that and future value of an account. So first, let's find the interest on $7,000 compounded quarterly at 3% for 5 years. All right, so look for what you're supposed to find first, which is the interest, and then also look for a clue as to which type of interest this is. So we're starting to develop additional formulas, and at this point you know the formula for simple interest and also for compound interest. All right, so those are your two choices. Now this is compounded, so that's the key word that tells us which formula to use, and that's the one that's A equals P times 1 plus R over N to the NT. All right, now let's talk about entering this in your calculator. There is one set of parentheses that's implied here, but not actually written. So if you're entering this all at once in your calculator, depending on the one that you have, you may need to put parentheses around the exponent n times t. If you don't do that, then sometimes the calculator thinks it's just to the nth power, and then this whole thing gets multiplied by t. Okay. Now the exception to that would be if you have a calculator that has kind of like a blinking cursor up in the exponent, and if you can clearly see that what you're typing in, when you put in the time, is a small number that's written as an exponent, then you know that you don't need parentheses. Some of the Texas Instruments, the TI-84 Plus Silver Edition, I think, has that feature. The regular TI-84 does not. And if you have like a scientific calculator like a Casio or a TI-30 or a basic 4-function calculator or a cell phone, most of those you will need to put parentheses around that exponent. Alright, so let's fill in the information we know. And notice in this formula we don't actually have the interest represented anywhere. So what we need to do is backtrack. Once we have the future value, we're going to use that formula A equals principal, future value equals principal plus interest, and then we can just subtract the principal from both sides to find the interest. So that's where we're headed. Okay, so we don't know the amount. We do know the principal. It's $7,000. We do know the rate, 3%, so 0.03. All right. N, what is N? Well, it's the number of times per year that interest is compounded, and in this case it's quarterly, so N is 4. Okay, and then the time period, which is how long this money is invested for, and that's 5 years. Okay, so times 5. Okay, now a second option, you may choose to simplify this as you go, so that's a good idea as long as there's no rounding involved. Alright, so for example, 4 times 5, that's going to be a nice number without any decimal part to it. So you can go ahead and simplify that before you enter it in the calculator if you like. And then I would also look at this part in parentheses. Okay, using order of operations, that's the part that gets done first. Alright, so if that works out to be not an exact value and not rounded, you can go ahead and figure that out. So this one is 1.0075, and that's an exact value, so I can replace that, okay, to the 20th power. Okay, so then entering this in the calculator, we would just do 7,000, and then you can either do times or just the symbol for parentheses depending on your calculator. Alright, and since we've worked this all out, I guess you don't even really need the parentheses. Alright, and then there's usually an exponent key. Look for something that's either a little caret or maybe y to the x or a to the b, something like that. Okay, that indicates an exponent. Mine has a caret. And then the exponent of 20. Now your calculator, if you have one that has order of operations built in, then this should do exponent first and then multiplication, which is what we want. So try it out, make sure you get the same answer here. And this turns out to be, let me put this up here, this is $8,128.29. Now that's a rounded value. I am rounding to the nearest cent. Okay, it was 0.288, and I rounded that up to 0.29. All right, so that's the future value. Now how do we get the interest? All right, so now we go on to that second formula. All right, A equals P plus I. So I know that that 8,128 and 29 cents value, all right, that's a combination of the $7,000 principal and then some amount of interest. Okay, so if I subtract 7,000 from that amount, whatever's left would be the amount that is interest. Okay, so interest is 1,128 and 29 cents. All right, and that's how you use the compound interest formula. We'll do one more example. Find the interest on $11,000 compounded daily at 5% for 6 years. Assume a 365-day year. Okay, so we need the compound interest formula first. Okay, so A equals, then principal, 11,000, then 1 plus R over N. So the rate is 5%, that's 0.05, divided by N. Okay, so I want to look for that phrase that tells me how often interest is compounded, and it's daily, which means 365 times in a year. So N is 365. Okay, and then the exponent would be N, 365, times T, so how long is this interest building? And it's for 6 years. All right, so times 6. All right, now this one, when you go to try to simplify, okay, we can do 365 times 6, that's fine, but this part in parentheses, this does not work out to be an exact decimal. We would have to round that, so I'm just going to leave that as is to get a more accurate answer. And I think the only thing that I will do is just figure out what is 365 times 6. Okay, and that's 2,190. Okay, so in the calculator I would do 11,000, and then I do need a parentheses. Some calculators still want you to put in a multiplication sign before it. Okay, 1 plus 0.05, then the division symbol indicates a fraction. Okay, divided by 365, close parentheses, then whatever your exponent key is. Okay, and then if you worked out the 2190, you could put that here. Or if not, then you would just do another parentheses, the implied one. Okay, and the entire exponent is 365 times 6. Okay, I used x's here for the multiplication symbol. All right. So that should give you a value 14,848 and round to 14 cents. Okay, so now if we subtract the principal from that future value, that should give the interest. Okay, so that number, okay, minus 11,000. Okay, so this is future value A minus principal equals interest. Okay, and that's 3,848 and 14 cents. All right. So here's a big caution note from your textbook. Watch for when you can and when you can't simplify the part in the parentheses. So we already talked about this, but in example 2, we did simplify because we could do so without rounding. But when we got to 1 plus 0.05 over 365, this would have been a much longer decimal and probably would have needed rounding. Okay, so this is interesting. If you rework the calculation but round that value, the result is off by over $1,000. So you wouldn't think that it would really matter that much, but it actually does. Okay, we'll stop there, and in the next video I want to do a couple examples with you of using logarithms to find the time needed to reach a potential savings goal. So we're still going to use the compound interest formula, but we'll rework it in an algebraic way.